Hello, everyone. Good morning, good afternoon, good evening to you all over the world. It's great to see the list of places that you're dialing in from. This is fantastic to see you all. I hope you're all well and your families and colleagues are safe and well in these challenging times. We're here today for the latest in our Innovation Network webinar series. And today we're taking a deep dive, a full hour into the topic of algorithmic business thinking, building a periodic table of digital and human elements with my friend and colleague, Paul McDonagh-Smith. Paul's a senior lecturer at the MIT Sloan School and also a digital capability leader in executive education. Paul and I started working together now, I think, well over a decade ago. And I found him, or if he found me, or perhaps we found each other, and worked together, in fact, virtually in a virtual world that Paul and his team had created for learning and other kinds of activities. And we didn't meet each other in person until, I don't know, we've been working together for a year or maybe two. And when we did, I have to say, it's like we'd been working in the same office for all that time. That's how impactful that kind of technology and learning platform could be, even way back then, a decade ago. Paul has continued to drive innovations for us and in the industry. He's highly sought after as a speaker and an expert in the intersection of technology and learning and business. And we're very excited that he's been able to find time to join us today for this webinar. So today, what Paul will cover is he will help us understand this new term, ABT. I'll leave it to him to define, and he'll introduce us to some ideas that he's created in the course of this work to really help us understand how human beings and digital technologies can come together and really have the whole be greater than the sum of the parts, if you're familiar with that British expression. So Paul, I'm going to hand over to you now, and I'll be back in a little while to help manage any questions that have been coming in through the question and answer section. So please do feel free to post questions as we go through, and I'll come back and help Paul sort through those questions in a little while. Paul, over to you. Welcome.
Thank you. So Peter, Lauren, team, thank you very much for kind of introducing me so kindly this morning, this afternoon, this evening, wherever you are. Also, just a quick thank you to those of you who are attending, who actually reached out to me before this event from places all over the world, from Zambia, Australia, different places, just to let me know that you were going to be attending today's session and giving me a little bit of support and kind of letting me know that you would be here. So thank you for that. So without further ado, let's get into this kind of. So what, in fact, is algorithmic business thinking? And some of you may have had the opportunity to kind of listen and tune into a previous webinar we did on this topic, or may have seen certain things online about this. So I'm going to kind of take a little bit of a different perspective today. You can go back and watch those things. But ultimately, I just want to introduce you at a high level to the concept, which is that fundamentally it's a toolkit, it's a mindset, and actually it's a common digital language. And we'll talk a little bit more about that shortly. Why, in fact, is it relevant today? Well, we believe it's relevant because it's going to help us, along with other tools and other kind of mindsets, to actually move the challenges that we face into opportunities for sustainable and profitable, productive growth. And in a moment or two, we'll actually start by taking a particular problem, a challenge, or perhaps even an opportunity, if you will, and use our algorithmic business thinking approach to break it down. Okay, so how indeed does algorithmic business thinking work? Well, in essence, it's about fundamentally the overarching idea here is one of consilience. And I've borrowed that term from E.O. Wilson from his 1998 book, in fact, which the term consilience itself, hinting at this idea of unification, of uniting. And here, with algorithmic business thinking, fundamentally, we're looking to unify human and machine capabilities to use Peter's kind of expression, such that we create a solution that's more than the sum of its parts. Now, let's actually begin by introducing the foundations of ABT. Algorithmic business thinking is built upon 4 cornerstones of computational thinking, in fact. The first of these is decomposition, the breaking down of a complex problem into a series of smaller questions. Breaking the complex problem down until we arrive at a problem we can actually fix, and then working on the next problems, toppling the row of dominoes, if you will. And how do we do this? Well, we do it by employing the second cornerstone, firstly, pattern recognition. And pattern recognition is building or borrowing patterns of success in one area and then simply applying them in another. Then we apply the third cornerstone, abstraction, which is the separating of signal from noise. And by doing so, we provide some clarity to the actual problem we have in front of us. We move the unnecessary stuff out of the way, and we have the opportunity then to begin building algorithms. Now, what's particularly important with regard to algorithmic business thinking is that the algorithm part, this is actually humans and machines working together in new partnerships. New partnerships that in fact recalibrate the roles, the responsibilities, and the relationships between me and you, between us and the technologies we work, live, and play with. So why don't we take this opportunity to actually take our 4 algorithmic business thinking cornerstones and apply them to a problem, to a complex challenge of how we might respond, react, and present ourselves to each other in our teams, to our customers, to our broader communities in this time of pandemic and post-pandemic opportunity. And the first thing I'd like to say is that I would prefer not to actually term this as a time of recovery as such, because I'm not sure, well, I don't think we're going back to any version of what might be perceived as normal. But instead, I'd like to refer to this as a time, not recovery, but discovery, a time for exploration and engagement. Okay, so what we can do is let's start breaking down our complex problem right now together into some smaller, more manageable parts. Some questions as we decompose this idea of what are we going to do pandemic into post-pandemic kind of period. So some example questions might be, how are we going to turn up every day and work with each other to grow our individual and collective strength? How indeed are we going to support each other? How are we going to support existing as well as new clients and customers? And how are we in our teams, in our organizations, going to build competitive advantage, competitive differentiation? How, in fact, are we going to create the futures we want rather than run the risk of inheriting ones created by our competition or simply visions or versions of the future that aren't really aligned with where we want to go? Now, to answer these questions, I would argue that we need to look for the patterns. Patterns from inside and outside of the environment we work in that can help us move from challenge to opportunity. We need to recognize the patterns of our successes, but also our failures, and evolve. Evolve like the elite digital professionals we either are or will aim to become. And we also need to prepare. We need to be ready in the moment to be able to reflect, respond, and react to the challenges and the opportunities that come. We need to recognize the patterns, build knowledge from those patterns, practice applying that knowledge so that when those opportunities do turn up, we're able to grab them faster than our competition. And then we need to abstract. This idea of separating the signal from the noise, the important from the distracting, to bring into really sharp focus the value that we can create and deliver for our customers and communities. But we don't just need to bring the value into focus. We need to be able to communicate it better than our industry competition. And for this, I think we need a common digital language. And how are we all going to do this? Well, I think this is where the algorithms come into this. Algorithms, that is the step-by-step processes that are in fact instructions for fixing the selected problem. But as we've said, these algorithms aren't or won't be written in code or data alone. Instead, they're human and machine algorithms working together in a new partnership that allows us to frame new questions and work towards new answers. And so what are these algorithms actually built with? So I would argue that they're going to be built with the digital and the human elements we have at our disposal today. And this, as you'll see, is kind of leading us in to our main piece of the conversation around creating a periodic table of digital and human elements. But before we actually take you in to look at this actual table of digital elements and human elements, we'd just like to take, I suppose this is a 1 minute reflection stroke reaction time. We'd like you just to think, and if you don't mind, share with us in the chat box, the types of complex problems or complex challenges that you are seeing in your teams, in your company, or yourself, as you kind of re-engage with your communities and with your organizations and your clients and your customers. We're going to take almost like a tweet approach to this. So if you are inclined to put your answers into a text box, just could we ask that you do it in less than 15 or 20 words or less than 140 characters? Okay, so just take a minute, please, to reflect on this idea or this question. Okay, we'll give you another 20 seconds or so if you want to kind of just share some final kind of thoughts. Okay, so I can see a lot of kind of comments coming in there. Thank you for that. What we're going to do now in this next section is actually introduce a version 0 or 1.0 of a periodic table of digital and human elements that I think can help us construct those human and machine algorithms that, yes, can be used in this particular kind of question of how we're going to kind of work in the pandemic stroke post-pandemic period, but also very applicable for a broad range of business challenges. They don't all have to be super big and complex. They can be smaller ones as well. So as you can see here, just 1 minute. As you can see here, what we'd like to do is to actually ask you to, having reflected on these complex challenges, we'd like you to think about the way now that we can actually use our algorithmic business thinking process with its 4 cornerstones to actually be able to start moving towards solutions. And I just gave you a sneak preview a moment ago, but the periodic table that we're going to share with you will actually have 8 technology periods, as well as a series of human-centric elements. There are going to be 12 of those that we're going to actually look through. Okay, excuse me for this technical problem here. Okay, so I'll just give you a moment to have a quick look at this, and then we'll start kind of walking through it. As I mentioned, this is simply a version 1.0, or a version 0, in fact, of this idea of a periodic table. And in a moment, once you had a quick look through this, we'll start walking through the various families, as well as the human-centric capabilities. Now, in order to kind of just introduce this a little bit, I think what I'd like to do is just ask you all to kind of step back in history a little bit, to go back in time. And what we'd like to do is perhaps ask you to go back to your high school chemistry classes or your chemistry labs. And in fact, if you were even so inclined, you might close your eyes and picture the scene back there for a moment or two. You remember those Bunsen burners, the white lab jackets, and somewhere in front of you, pinned on the wall, was a copy of the periodic table. Now, in my school, we were actually taught three fields of science. We were taught physics, biology, and chemistry. In physics, we learned about Isaac Newton's laws, for example. In biology, about Charles Darwin's theory of evolution. But it was actually Dmitri Mendeleev's periodic table that I have to admit really caught my imagination. And if it's okay with you all, I'd like to take just a couple of minutes to explain why. Firstly, through the eyes of that 13-year-old pupil, and then secondly, through the lens of algorithmic business thinking. And of course, I invite you to do the same. That 13-year-old version of me was, I have to admit, a little bit more interested in neutrons than newtons, perhaps, and more taken with experiments than evolution itself. It helped, of course, that we had an incredible chemistry teacher who made us feel that we were actually chemists. I remember he used to build models of various molecules, and you actually felt that you were walking around inside them. And so now, every time I think back to a chemistry lesson or a chemistry lab, I always see a poster of the periodic table hanging on a wall in my mind. Its quiet order, its elegance, belies the struggles, the torments, the generations of work that went into its creation. And I think in the same way that Newton's laws and Darwin's theory had laid the foundation for physics and biology respectively, Mendeleev's periodic table, I think, did a similar job for chemistry. And quite simply, I was enthralled. So now, if I fast forward to my role here at MIT Sloan and our work on algorithmic business thinking, how has the way I look at Mendeleev's periodic table changed? Well, the first thing to say is that I'm equally enthralled, but perhaps now for different reasons. Now I can see it, or I look at it through the lens of algorithmic business thinking. And so if I apply an algorithmic business thinking lens to Mendeleev's periodic table, I don't just see our 4 cornerstones of decomposition, pattern recognition, abstraction, and algorithms in play. What I also see is that we have a potential opportunity to do for the digital economy what Mendeleev did for his field of chemistry. Let me explain what I mean by this. When, way back in 1869, Dmitri Mendeleev published his first version of what ultimately came to be known as the periodic table of his elements, he referred to it as an attempt towards a chemical conception of the ether. He was recognizing that the science of chemistry was more complicated than many scientists of the time thought, and that the natural world involved more than air, earth, fire, and water. In essence, he was trying to break down the complex problem of the relationship between chemical elements, to recognize their patterns, abstract and sort the key points. For example, their atomic weight, so that he could write an algorithm. In his case, in the form of his periodic table, which provides a step-by-step set of instructions regarding how elements interact with each other. And I suppose the bottom line is that I think we need to do the same today for our digital economy, as well as for the society in which we all live and share. I think we need a periodic table of digital and human elements that allow us to break down or decompose the complex challenge of the relationship between the digital elements we have at our disposal, identify their patterns, and abstract to what is important by filtering out the noise from the signal. And by applying these first three cornerstones of algorithmic business thinking, I think we will be able to enable our companies to create human and machine algorithms that actually convert the challenges posed by the digital economy into a series of step-by-step instructions with which we can create stable compounds and molecules that in turn enable sustainable growth. And I suppose, curiously enough, this brings us back to Newton and Darwin again, in the sense that in creating our periodic table of digital and human elements, we're applying aspects of Newton's laws of motion that describe the relationships between an object and the forces acting upon it, and key elements of Darwin's theory of evolution, such as constant change and natural selection, where it's not necessarily the strongest that survive, but the most adaptable. So I think we can learn and apply a lot of lessons from Mendeleev, as well, of course, as from Newton and Darwin. And these lessons can help our organizations perform a type of almost corporate judo move on disruptive technology and convert its challenges to opportunities. You know, the idea of using its own energy to counter its threats. So what elements have we got in our periodic table? When thinking or talking about the elements, I think it's useful to kind of, in our minds, glance back at that poster we all remember hanging in our chemistry labs and classrooms. Mendeleev's table provided an orderly way of looking at the linkages that lie among and between the various elements, from hydrogen, element number 1, all the way through to organosin, element number 118. And let's just think about hydrogen for a moment and what I consider to be its equivalent in the digital world, data. Hydrogen is the most abundant chemical substance in the universe and was assigned an atomic number of 1. In our periodic table of digital elements, we're assigning data a digital number of 1. It's our most abundant element and can be used to create important molecules and compounds. So if we think about it, hydrogen and oxygen combine to form hydrogen oxide, which we know more commonly as water, of course. Carbon, hydrogen, and oxygen join forces in, quite complex arrangements to yield numerous hydrocarbons, gasoline, alcohol, methane, plastics, and lots more. And for example, carbon, hydrogen, oxygen, and nitrogen sometimes perform almost a kind of dance that, when it's choreographed correctly, forms them into a series of interconnected rings. Now, if this ring, or this ring of ring, forms around an iron atom, we know the molecule as hemoglobin, the protein molecule that carries oxygen through our bloodstreams. If the same molecule, with some relatively minor changes, forms around a magnesium atom, we know it as chlorophyll, the compound that makes it possible for plants to convert sunlight into complex sugars through photosynthesis. Now, today, as we sit early on the second half of our technology chessboard, we have a collection of new technologies that are being discovered and explored. And I think, like the chemical elements, our digital elements can also be combined to form complex, valuable molecules. Data, our equivalent of hydrogen, will be key to the formation of a number of organizational molecules. Here in our periodic table, or this first draft version of it, in our periodic table of digital and human elements, we've grouped families of technologies based on their attributes, their characteristics, and their patterns. We've included periods, or you can see the families here, of data, AI, realities, digital realities, that is, so augmented reality, virtual reality, mixed reality, virtual worlds, etc. Communications, IoT, compute, cyber, and analytics. Now, in Mendeleev's periodic table of the elements, each of the elements in each column display similar behavioral characteristics. And we're trying to do the same in our periodic table, grouping elements, in our case, by their organizational capability and characteristics. And when Mendeleev created his original table, in fact, during the development of many generations of the periodic table, he was looking for patterns that indicated elements that would fit in each column or period and shared predictable characteristics. And very interestingly, even when a gap exists in the table, because an element hadn't yet been discovered to fill it, Mendeleev left a space, suspecting that whatever element was meant to be there would in fact be discovered or uncovered at a later stage. And as you can see in our periodic table of digital and human elements, we've grouped technologies according to their behavioral characteristics, their impact on people, impact on business and society. And also, we've left spaces for new elements to fill. And like Mendeleev, we recognize that given the rapid pace of change, the evolution of technology, gaps will be accounted for as things evolve. Another similarity, perhaps, with Mendeleev's table is the degree to which the elements therein tend to be cooperative and collaborative. For example, the alkali metals and the halogens tend to be extremely reactive. However, once combined, they form stable, low energy compounds. Noble gases, as you'll remember, can interact with other elements without actually reacting at all. Now, I might argue that technologies behave similarly. Some incline towards collaborative reactions, forming functional and useful molecules with other elements, while others are more useful when used alone. For example, we might consider IoT to be a valuable element in its own right, but then when it's combined with elements such as wireless broadband, cloud, or analytics, the resulting molecule, while complex, is arguably more valuable than any one of the elements that help to form it. And today, in our teams and companies, we find ourselves experimenting with technology elements in their raw form and in the compounds that they form. For example, by combining technologies, organizations can create, I think, competitive advantage. How technologies can or should be combined will obviously change across companies and industries and over time. But the concept of combining technologies such as we see here in these various families, such as AI and machine learning with AR and VR, with mobile computing and big data, to form our equivalent of chemistry's chlorophyll or hemoglobin molecules, is, I think, an important idea or important concept for us to explore and experiment with. I think competitive advantage will lie increasingly in the compounds and the molecules of the technologies that we share and create together. Now, these technologies, a number of the ones we've just mentioned, as well as a number in the actual table here in front of you, are pretty remarkable by anyone's measure. And perhaps all the more so because most have been uncovered or discovered only in the last few decades. From a business perspective, let's not forget that these technologies create and consume massive volumes of data, or hydrogen, if you will. They do something to it, and they yield useful outcomes and insights for our business and society. But if we don't take that insight and use it to make a more informed business decision, or improve how we deliver a customer experience, or change the practice of medicine, or build better cities and towns, then what's really truly the point of having all of this incredible technology at our disposal? I would probably go as far as to say that those of us who live our lives in the technology sphere have somewhat of a responsibility, not only to our customers, but to our families, friends, colleagues, and communities. A responsibility to help them understand where the value lies and how to mine it from these four elements or technologies, the ones we have in front of us here. Now, if we don't accept this responsibility, I think we run the risk of technology development becoming either an economic or academic exercise only. And that's perfectly reasonable in lots of contexts and for lots of reasons. But I would argue doesn't really get close to the real true promise of technology, which I would argue is at least twofold. Firstly, to enable humans to exceed our physical and mental limitations. And then secondly, to enable us to have a positive impact in our societies for the advancement and well-being of all. Now, with regard to this second ambition, I think algorithmic business thinking, with its toolkit and its mindset and its digital language, will help us equip and be well positioned to frame and fix our most pressing organizational and societal issues. I'd like to think that it in some ways helps us move from challenge to opportunity, from inaction to action, dark to light, can't to might type of thing. And for this reason alone, I think the combination of technology's capabilities with humanity's innate instinct to make sense of what technology tells us is potentially the most important compound of all. And this is where we're kind of looking at the linkage between the digital and the human elements. So I'd ask you just to cast your eye to the two green kind of horizontal periods at the bottom. And just before I kind of talk through these a tiny bit, I just want to share a little bit of my thought process and rationale regarding the inclusion of human elements in our periodic table. Now, at a time where we all recognize the importance of STEM type skills in the digital economy, you would be excused, of course, for finding it a little bit curious that I'm including this list of human elements in a periodic table. We've been thinking for quite a while about a core tension that I often hear in AI discussions at conferences, in research, etc., about what humans and machines are both bringing to their partnership. And personally, I found myself more and more interested in the ways that humans and machines could and would complement each other, rather than look to compete with or substitute each other. And by extension, in this connection, I found myself thinking about Morovic's paradox, which reminds us that often what's difficult for humans is easier for machines and vice versa. And Polanyi's paradox, that's often summarized as we know more than we can tell, which hints at the difficulties related to codifying tacit knowledge into explicit knowledge, and what that might mean for the tasks and the jobs humans and machines are taking responsibility for. And ultimately, thinking about the implications of these two paradoxes led us to recognize that having them in place might actually lead to another paradox at play that we should maybe be thinking about. And we kind of term this as an Abt paradox, which is that today's and tomorrow's companies will be increasingly reliant upon human-centered capabilities, not only technology-centered ones, in order to secure sustainable and profitable futures. Now, this may seem or may appear somewhat contradictory, but I think, or we think, it will be the key human-centric capabilities that actually help us unlock the potential of the digital age, not transformative technology on its own. And so this behind all of these kind of ideas is the concern that if we were actually to build our organizations upon silicon-based digital technologies, in some ways, we'll be building upon pillars of sand, where instead, companies whose focus is on using algorithmic business thinking and its digital and human compounds will be creating companies fit for purpose in the digital economy upon very firm foundations. Now, you can see the 12 human-centric elements that we've included here: creativity, curiosity, critical thinking, compassion, collaboration, community, communication, courage, culture, commitment, celebration, and consilience. Coincidentally, all starting with a C that might just denote their carbon world origins. I'm just going to say a sentence or a maximum 2 about each. So curiosity it's the energy source that drives us forward. It enables exploration and helps us sustain our passions. It weakens the status quo while at the same time fundamentally strengthening our teams and companies. Creativity, definable as a desire to evolve, benefits massively from diversity, which I would argue or consider to be almost our universal human trait, which as such needs to be engineered into technology solutions to offer an antidote to codification of bias that we see. Now, with critical thinking, we're recognizing the value of being able to recalibrate our thinking in a world that increasingly offers dichotomies and polarities of choice. Whether physical or digital, product, platform, human, machine, being able to apply critical thinking will help us find our place and navigate the digital economy more effectively. I also think we need to think proactively rather than just reactively with regard to compassion. The idea of leading with compassion rather than following up with it. We need to move from an I to a we type mentality as we transition further into the digital economy. And this idea leads into the element of collaboration. So just a little point about collaboration. Often it seems that people consider collaboration to be somewhat of a soft skill. Personally, I've found effective collaboration to be complex and often challenging. There can be many reasons for this, of course, but the one I'd like to highlight here is related to trust. In order to collaborate effectively, particularly on projects where there's a shared risk, I think it's critical to build trust early on in the relationship. And to do this, invariably, we have to give something first. We have to show that we can be trusted before those that are collaborating with us are prepared to put their full confidence into the shared endeavor. Now, with regard to communication, I simply want to stress the value of moving from a dynamic where we write and read technology to one where we speak it also. And this point goes back to the very first slide where I mentioned ABT as a toolkit, a mindset, and a digital language. Just a quick point about the idea of a digital language. I'm very inspired by the work of the Professor Emeritus, Noam Chomsky, who makes a very interesting kind of assertion that the principal function of language isn't to communicate, but to link interfaces. And I think if we hold that in mind when we're thinking about communication, particularly humans and machines, I think it's fascinating at a time of exponential technology growth to think about the number of interfaces we're creating and how we are going to link them together. Okay, so just one small point with regard to the idea of communication and language. Community, we need to think of networks not as being physical or digital, but being physical and digital. We need to be inclusive, to add nodes and not exclude them. And we need to be particularly interested in the flow between the nodes. You know, the ways in which we share information, knowledge, experience, and identity. And when it comes to the gene of courage, I simply want to stress courage in the sense of exploration, the courage to take steps into new areas, to explore success, explore failure, and to learn our way forward. life and work isn't a static prediction problem. We need to learn as we move forward and have the courage to try new things and new thinking. With regard to culture, algorithmic business thinking with its toolkit, its mindset, and the digital language is asking us not just to move from centralized control and command types of structures of leadership and management. It's not just asking us to move from those into more decentralized ones, which are identifiable by cultivation, collaboration, cooperation, etc. But in fact, to go further and embrace a culture of exploration and engagement. Commitment, this act of binding ourselves to a course of action, is critical, as is the ability to stay that course of action, to not give up. And interestingly, I found that when I felt close to throwing the towel in, it generally shows that, or generally find that I'm nearer than I thought to making real progress on an objective. So staying in the game is important, of course, as well. Celebration, this might seem curious, but I think it's central to our progress. We have to celebrate and explore the successes and the failures. We need to recognize both equally, recognize their patterns, and use those patterns to help us chart a path forward. Now, the final element, human-centric element here that I want to mention is consilience. It's the unifying force. It's that E.O. Wilson kind of related thought that I mentioned before. It's a unifying force that connects our physical and digital business contexts. And this concept of uniting and unifying is truly at the heart of algorithmic business thinking, its toolkit, its mindset, and the language, and the periodic table. And so in order to evolve the individual and organizational capabilities to be effective today, I really think we need to embrace this idea of unification, unifying our industrial past with a digital present and future. We need to take the best of both worlds, combine them such that they create solutions more than the sum of the parts. And this unification includes creating compounds where digital technology elements are actually bound together by human elements. So I think there's a lot of great lessons that we can take from Mendeleev and from his work, and also his general approach. You know, I mentioned this was back in 1869 when Mendeleev published his first version. At that point, he'd been working on these concepts for more than a decade. There's a story that suggests that kind of one evening in February 1869, he had actually, whilst he'd had an intuition for patterns for a long time, he actually chose to write out the elements, the 63 elements on pieces of card, and kind of just try and order them on his desk, on his table, and try and identify patterns further. He fell asleep, you know, after having not worked for days. This is how the story goes, and awoke with the concept and having conceived the concept of the periodic table. What we're looking to do here is try to find ways to make sure that, in line with the Abt Paradox, that we're actually very much focused on the human-centric elements as well, because we feel that by incorporating these into our work, we'll be well positioned to actually take advantage of the digital capabilities that the technology elements or the digital elements are actually providing us with. So what I'd like to do now, just for a moment, is just ask you to take literally a minute or two to think about these digital and human elements, and share with us if there are other elements that you would include in your periodic table, or even make a reference to ones that stand out to you as being particularly important. So again, if you wouldn't mind, in your text chat box, just short kind of thoughts with regard to the digital and human elements that are important to you in your organization, that you're using or thinking of using, or would like to see on this table. Okay, we'll give you another 30 seconds or so, just to kind of finalize any thoughts or kind of reflections, reactions. Okay, I shan't do a 10-second countdown, but we're getting close to it, ladies and gentlemen. Okay, thank you. As we mentioned, we're particularly kind of interested in the ways in which we can kind of apply these human-centric elements and use them almost as the bonds that connect our technologies together. Okay, so what we'd like to simply share with you for just literally two or 3 minutes here before we get into an opportunity for some questions is just really to share this 3E model with you. And it really builds on some of the ideas we've already kind of shared with you around the need for exploration, the value of experimentation, and how both actually help us evolve our teams and our organizations. With regard to exploration, I simply wanted to kind of stress or kind of introduce one particular point. We've been fortunate enough to do some work with colleagues at NASA, and there's a gentleman there, Dr. Jim Garvin, who in an effort to explain to me kind of key concepts of space exploration, used the term forever frontier. And his point was that when we think about space exploration, we should always think of it as something that belongs to us as well, because we are part of the same system. Okay, whenever we're thinking or whenever we're listening to kind of the sounds being transmitted back by Perseverance, whenever we're kind of reading about kind of NASA's and SpaceX and all of these plans for Mars or for Venus or what have you, we shouldn't think of it as being something separate from us, because we live in the solar system as well. We share kind of space together. And I'd like us just to kind of hold this idea in our minds with regard to the digital economy as well. All of us will be using digital technologies in kind of different ways. We will be kind of formulating hybrid kind of compounds with physical kind of elements as well. And you will have noticed that, similar to the NASA point around a forever frontier, the digital economy and the digital frontier isn't one where we kind of reach a kind of a destination. It's a continual journey. As we step forward, so does the horizon. It moves further away as well. So I think it's very important for us to kind of bear in mind that we exist within this system, and it's not something that's going to easily kind of be defined by a destination, but rather by its journey. And with regard to experimentation, simply want to share with you kind of this idea of using our 4 algorithmic business thinking cornerstones of decomposition, pattern recognition, abstraction, and algorithms, where the algorithms are the humans and the machines working together, in order to allow us to evolve in our organizations and teams, to being translators, able to convert the value of computer science into business value, but also convey the business needs to technology audiences in an effective way. And so this idea of a digital language built on kind of Noam Chomsky's point around linking interfaces, I think provides the opportunity to allow us to unify and connect technology, non-technology kind of elements, unify inside and outside of our organization as well. And one of the important things, of course, with regard to learning any language is to be able to listen effectively. Yeah, we can never really speak a language well unless we listen and respond and react accordingly. And so with that in mind, I would just like to ask you our final kind of reflection, just for 30 seconds or a minute, around how you are going to explore, experiment, and evolve in your teams and organizations moving forward. Okay, so we'll just give you 45 seconds or so to kind of enter in some thoughts to the chat box, or simply reflect on this point. thank you, by the way, for entering those thoughts or simply reflecting and kind of reacting to the points that have been shared. So a number of the points that we've talked about, or I've talked about over the last 50 minutes, they're really a small insight or kind of an overview of the insights, the frameworks, the models that are part of our Algorithmic Business Thinking program. We very much kind of welcome you or invite you to join our program and in fact our ABT movement. You can see here the kind of image from the webpage for the program. If you are interested in taking the program, the next one begins on June the 2nd, the orientation module. And as I say, we'd be very, very pleased to have you join us. It's a program built, we have a coding platform. You'll learn how to kind of read and write and improve algorithms. We use podcasts. We have a virtual environment for kind of office hours and kind of peer learner kind of networking. So a very kind of immersive, hopefully, and engaging experience. So with that, I'll actually pass this back now to Peter and the team. And Peter, you can let me know if there are any questions or anything you'd like to.
Great. Thank you, Paul. And yes, there's been, while you've been talking, a great conversation going on in the chat and a lot of questions coming in as well. And we won't get to all of them, but Paul has offered to help answer some of the questions that we won't get to now afterwards, and we'll share those answers also. But a couple I thought that came in that might be quite close to your heart as well. Ramu asked about, he was very interested in this idea of technology and people, and in particular how technology, enables humans. And he was thinking, he asked a question about how could this approach help with, for example, really empowering people with disabilities, both in the workplace and in life.
So I think that I'll kind of answer it in two parts, kind of, very briefly. The first part is that I think it's always been part of kind of human nature, if you will, to kind of use technology to do things that kind of are outside of our physical or mental kind of capabilities. So from the very beginning, when kind of fishermen were building nets, they didn't try to build nets that kind of would allow us only to kind of to kind of catch the same amount of fish that we could carry. Yeah. And so there's always this idea of kind of using technology to augment and to expand and to exceed. And I think when it comes to technology kind of enabling interactions of the type in the question, we've experimented with this a lot, haven't we, Peter, in the team, around using things like telepresence robotics for individuals who, with mobility challenges and impairments, to be able to get to campus. I think what I would argue is that the technology has the capability to help us in numerous ways, and it's the human-centric capabilities that are going to make this a reality. So the idea of compassion, the idea of creativity, thinking of smart ways, wise ways in which we can use these technologies to kind of make sure that everybody is able to realize as much of their individual potential, and then that in turn supporting the collective potential we have in our teams, companies, society.
Great, thank you. Another question which I think could take another hour to answer, but I thought was a super interesting kind of approach. Forrest and others were looking at particularly some of the human capabilities and asking questions about what I might term anti-capabilities. So maybe in your periodic table, the equivalent is, I don't know, antimatter. I'm stretching the metaphor a bit too far, I'm not sure. But so courage, for example, people were asking about, what about sort of fear and cowardice? Is that sort of do these qualities have an opposite side, and how do you figure those into this model when you're actually using it in the real world?
Well, it's an excellent question, isn't it? And the first thing I would say is that I recognize, in fact, one of the past participants, a chap called Max Mayank, reminded me kind of that as well as having patterns, we have anti-patterns. Yeah, and so we need to be mindful of the flip side of each of these queens, if you will. Yeah, so the courage kind of is working against the fear. the creativity against the status quo. And we need to be mindful of kind of the counter forces. But the beautiful thing, I suppose, is that for every positive step, we're actually diminishing the opposite elements. Yeah. So for every kind of courageous step you take forward, you're kind of reducing, or we're reducing the fear factor. We're kind of reducing the risk of that kind of causing impedance in our systems. So I think in all cases, for each of these human elements, it's absolutely critical to kind of be aware of the flip side, the opposite, and the anti-pattern, or the anti, the opposite of these, because those are the things that can stop us in our tracks, and we need to have plans to manage them accordingly.
Great, thank you, Paul. Well, we're just about running out of time. There were a few questions about, sort of, this obviously was a very high level introduction to a large and sort of complex way of sort of set of things. And you've used, as you said, sort of in a very reflexive way, you've used the approach itself to try to break that down into a sort of a more manageable structure to help us think about this large and complex sort of system. Maybe if you could sort of in the last minute address sort of a set of questions about, so if people were to enroll in this course, can you just give a sense of the kinds of things that they would be doing that would really help them learn how to apply algorithmic business thinking to the problems that they're trying to address?
So one of the first things that we do in the program is kind of help participants actually frame business problems. Okay, and Peter, I know that's something kind of very close to your heart, and kind of a key kind of principle here at MIT Sloan, around making sure that we're able to frame problems and have problem statements that we can work with before we kind of jump to solutions. But individuals on the program, you're given the opportunity to learn some of the basics of writing, reading, improving algorithms. So there's actually a little bit of coding. We don't need any math or kind of any programming background. It just introduces us to some of the fundamentals and applies them, bridges them into our business practices. From there, we actually think about, well, things including kind of the periodic table of digital and human elements, but also almost a double helix kind of structure in our organizations, where we can unify the physical and the digital together. But we do that in a way where we're joined by 6 world-renowned kind of faculty from across MIT as well as MIT Sloan, to give examples of algorithmic business thinking in action, okay, practical kind of use cases. And in fact, what we've been doing as well, Peter and everybody, is we've been interviewing kind of past participants and talking to them about the ways in which they're already applying ABT in their workplaces. So all of those things kind of are kind of included in the program. And as I mentioned before, we do it in a way over a period of 6 weeks with office hours, opportunities for networking in virtual spaces, podcasts that kind of allow you to kind of take some of the key messages and kind of untethered from your kind of laptop, listen to them, whilst you're doing the dishes or kind of walking around the park and that type of thing as well. But ultimately, I think there was a person who was on the first run of the program, Martha Anderson, who kind of always repeated to me that one of the most important things was the fact that the program allowed her to understand that she needs to take the robot out of the human and put the human into the machine. Okay, so fundamentally, that's one of the key kind of lessons or takeaways from the program.
Great, thank you, Paul. That's helpful. And to answer one of the questions in the chat, no coding capabilities are required for this to participate in this program that Paul is describing. Actually, the platform, you learn a little bit about the principles of coding, but you don't have to have done any before. In fact, maybe that's one of the powerful things here is that everybody can understand and roll up their sleeves and do a little bit of coding. So with that, thank you so much, Paul, and thank you all 500 plus people who've been participating in such a lively fashion in the discussion. I think there's a lot of very rich contributions from all of you as well, which Paul will go through. And once again, if you'd like to sort of take an even deeper dive over several weeks with Paul into this topic, he does have a new run of the Accelerating Digital Transformation with Algorithmic Business Thinking course starting on June the 2nd, running through July 21st. And as Paul mentioned, that includes podcasts, so you can go out and enjoy either the sun or the snow, depending which hemisphere you happen to be in, whether it's summer or winter. Thank you for joining us all today. Please keep an eye out for the next in our webinar series, which is with Dr. Tara Swart and Dr. Aurélie Jean, who will be talking about how to boost our brain power with analytical thinking. So this seems like it might fit into some part of the periodic table, and maybe a deeper dive into that. And that will be on LinkedIn Live, which is a very interactive forum for us as well. So thank you all for joining us. Thank you, Paul, for a fascinating tour through your latest work. And thank you to the executive education team who have made this webinar work so smoothly as usual. Thanks all. Be well, be safe, keep on innovating, and we'll see you all soon.
Thank you.